Greetings to all. I am Dr. Muhammad Shanawaz, Associate Professor of Computer Science from Jamal Muhammad College. So today we are going to discuss about an important topic from data structures, that is how to delete a last node from a singly linked list. So the algorithm is given here. The procedure named delete end node contain the variables. What are the variables we are going to use in this algorithm? That is given here: start information, link, location, and pointers, available memory. If start is equal to null, so this means that if there is no node is available in the memory in the linked list, we cannot delete anything. So whenever we are inserting an element, we have to check that whether the memory is full or not. So while deleting a node, we have to check that whether any item is available or not. So that being the case, if the start is equal to null, that means there is no element is available. The sorting pointer, what is that? It points nothing. That means nothing is available. So this being the case, we cannot delete any element because there is no node in the linked list. So that being the case, you have to, that is, publish a message, write underflow. Now the algorithm get exited. The second step is in which we are checking that the starting point, if it is equal to null, that means that is the link part of the start is null. That means the link is not pointing any other element. See, for example, this is the starting node, and let us consider if it is not pointing any that is element, that means what is that? It is null. The starting node is null. This means that you are having there is only one node, that is the last node. So that you have to store the value, that is the starting address, in this variable, that is PTR, and make this starting point as what is that. So actually the starting address is 10. So store this value, that is in PTR, and make this value as null. So this means what is that? This element, this node is get deleted. Now what you have to do, this node should be, that is stored in the available memory. So for that we are writing these statements. In the available memory we have some location. Let us consider that is 25. So in the location 25 we have to, that is, store this deleted node. Okay. So for that what we have to do, that is here actually the starting value is stored in PTR, and make this what is that start as null. Start is equal to, that is null. This part is over. Now what you have to do, you have to store in the link part of the PTR. This is PTR. Okay, this is PTR. In the link part of this PTR, you have to store the address of this available memory. So what you have to store, that is 25. So what will happen, and this PTR, the PTR is stored in the, what is that, the available memory. It is stored in the available memory. So the deleted node, the PTR is a deleted node that is stored in the available memory. So that that is explained here. This is over. Then the next step is we have to find out the last node. Not to delete the node, we have to find out the last node. So for that, what we are doing, a technique is we are following is just we are keeping a pointer, that is PTR, in the start node. So PTR is equal to start. Okay. We are going to, that is find out the last node. So how we are going to find out? We have to, that is, check the link part of the link part of what is that, each node. What is the link part? So the link part here, the link part is, it is nothing but 20, the link part is 30, it is 40, and finally that is null. We have to find out this node. So for that we are using the pointer, that is PTR. So what is the value of PTR now? The PTR is now, what is that? It is 10 initially, because what is that? We are assigning the starting value in the PTR. So we have to proceed this operation until the link of PTR not equal to null. We have to repeat. Which step? We have to repeat the step number 5. Okay. So in the step number 5, we are using one more variable, that is nothing but, that is LOC. LOC is another variable we are using. So we are storing the value of PTR in LOC. So LOC here, LOC is equal to 10 now. Okay, PTR is equal to 10. Now we have to do this operation, that is link of PTR should be stored in PTR. What is the link of PTR? This is the link of PTR. What is the link of the PTR? This is 20. So what you have to do? Now the PTR is equal to 20. This is the first step. Understand? Now we check that the value of what's that, the link of PTR, it is not equal to what's that? It is not equal to null. So we have to proceed the step number 5 again. Okay. What is the step number 5? This is the step number 5. So now the PTR is equal to 20. Now we are storing the value of PTR in LOC. Now LOC is also 20. But the next step is, what's that? The link of PTR is stored in PTR. So what is the link of PTR? Now what's that? The PTR comes here. What is the link of PTR? It is 30. So the PTR is, what is that? Link of PTR is 30. Okay. The next step, again, it is not equal to null. Again, the next step we are moving to. Now the PTR value is 30. PTR is 30. Now the location value, we are storing the PTR value in the location. So now the location is 30. Now what about the PTR? PTR is 40. It moves to, what's that? 30. From 30 it moves to, what's that? It moves to 40. Now PTR is 40. PTR is 40. PTR is 40. PTR is 40. Location. What about the location? Location is, what's that? The value of PTR stored in location, that is 30. Now the location is in, what's that? Location is in 30. The PTR is in, what's that? 40. Okay. Now here it checks, what's that? The value of the link of this PTR. The link of PTR, and it's now it becomes, what's that? It has become null. So the condition, what's that? The condition, the loop breaks here. So automatically the next step what you have to do is nothing but store null in the link part of the location. Where is the location is now? The location is in 30. So location is in 30. So what you have to do? We have to, that is, store null in location 30. So automatically what will happen? What happens? The last node gets separated. It is, what is that? It is taken out. So again we are following the same step. The taken node should be, that is, again stored in the available memory. That is what actually I explained in, what is that? In the previous statement. So here also we are storing this value, the same statements here. You see that? Available memory. Okay, in which we are storing the PTR value. The same step, what's that, followed here. So with that the algorithm is exited. I hope you understood the concept of deleting the last node from a singly linked list. Thank you.